Well, hello there, it's KP the Math G here. We have been doing left and right hand approximations from a problem. Specifically, the problem that I've been posing for the last 2 or 3 or 4 lessons is f at x is equal to 16 minus x squared, and we looked at the left and the right and the midpoint and the trapezoidal methods of finding area under that particular curve. Well, we're doing the same thing, except this time we're using a table. And I'm pretty sure that those of you who are taking an AP class will see this, definitely. If you are in a regular calculus class, I'm not sure if you will or not, but you might, I don't know. So be that as it may, we're going to go ahead and do one that is similar. Now, I picked the problem. I went through, matter of fact, I didn't have to go far. I started at the year 2000 and looked at some, free response questions, and I got to 2001 and I found one just like the way I wanted it, except I didn't use their exact same problem. I did use days and degrees Celsius, but they used 0, 3, 6, 9, 12, 15, and I went out one more, and I just did mine in increments of 2, so you can pretty well guess what delta x is right here. Okay, and I kind of went this route here with these numbers, using pretty much the same numbers that they used for Celsius. So, but anyway, still different numbers. The interval is from 0 to 12. As you can see, we're approximating. What we're doing here is we're approximating average temperature from time t0 to time t12. You are to write it like this. Okay, average was always, it's actually, the actual definition of this is 1 over b minus a, okay, from 0, or well, actually from a to b, A to b rather, from a to b, alpha x dx. Okay, that's the average of anything. So if you're looking for, say, in this particular case, we're looking at average number of days. Okay, average temperature, I mean, rather. So that's kind of where we're at. Okay, so what this table represents, it is a temperature of a pool of water. It is differential. It's a differential means that it is continuous, but it's also differentiable. All differentiable functions are continuous. That's what we need to know here. There's no gaps or jumps in this at all. Differential function w of time t. Alright, so we're going to approximate the average temperature. We're going to look at today, in this video, left and right hand approximations. Okay. Oops, my wife wants me to do something. So let me hasten with this one. Okay. Let me get it going with this. To do a left approximation, we are going to look at 1 over 12. Okay. That's from 0 to 12 times, okay, delta x. Well, that's in even intervals of 2, 4, 6, 8, 10, 12. Now, you will not always have tables where they're going to always be evenly spaced out, and I'll probably have to show you a video of that in another time. But these are all delta x. Delta x is, as you might guess, that is 2. Alright, So times delta x. Now, left side is just what F at 0. Alright, so 0, this is F at 0. This is F at 2, F at 4, F at 6, F at 8, F at 10. We are not doing F at 12 because we are doing the left side. Do a right side, you start from the right side and go left. And we want this many, 1, 2, 3, 4, 5, 6. Okay? We want these numbers here. Okay, you do all but the last one if you're doing a left side. You do all but the first one if you're doing the right side. Just remember that. Alright, so we're actually dealing with F at 0, which we already know is 24. It's already given to us. Plus 30, plus 27, plus 23, plus 20, plus 18, and that's it. I could probably squeeze that in. Plus 18. Okay. I didn't need that. Okay. Now, 12 times 1 over 12 times 2 is 1 over 6 in lowest terms. 2 goes into 2 one time. 2 goes into 12 6 times, so 1 over 6. Now we add all this up, and I have, say I have the answer. Okay, so let me see. I did change this number from 24 to 23, so I'm going to be off by 1. So I got 286, so it's really 285. I want to say that's 285 over 12. 285. 285. Okay. No, that's not right because I put this over 12. Okay, so I probably multiplied by 2 first. Okay, that's what I did. Alright, let's add this up. We'll see what we get, and that way we'll know. Let me get my calculator. And my wife she's washing dishes, but she probably wants me to help her with the dishes. So 24 plus 30 plus 27 plus 23 plus 20 plus 18. Alright, that equals 142. Okay, so 142. So 142. Alright, 1/6 of that. Okay. So 142, let's divide it by 6. 23.6. When you get the several 23 point, you get something like 0.666. It keeps on repeating like that. Well, let's put another one out there. Usually you can round off to 667. In the AP calculus you can do that, but if you recognize this is exactly equal to, well, approximately equal to this. Okay, bear with me, but exactly equal to 23 and 2/3. 0.666666 is 2/3. Okay. All right, so 23 and 2/3 is the left side. Okay. And that's how you do it. You just simply start from the left, F at 0, F at 2, F at 4, F at 6, F at 8, F at 10, delta x right here times 1 over 12, which is the average. Okay, you're taking the average over 12. Okay, alright, there it is. On the left side. Approximation. So we're going to put somewhere over here, the left approximation is equal to 23 and 2/3. 23 and 2/3. Now I want a right approximation, and I'm just going to leave that right there as the left approximation. Okay, so we're going to still do the right one. I'm just going to erase some of this and start over. I'm not going to flip the board over. So I'm just going to leave it like this. Let's erase these numbers. Although I don't have to erase all of them, do I? Okay, now, if we do the right side, we're leaving off F at 0. See that right there, everyone? We're leaving off this one. F at 2, F at 4, F at 6, F at 8, F at 10, and now F at 12. Alright, so just remember you have delta x. Delta x is 2, and 2, and 2 again, and 2 again, and 2 again, and 2 again. And that's what you got to remember. Your delta x is 2. Alright, so 2, and then of course 1 over 12. So 1 over 12 times 2, which again is 1 over 6. And then now F at 2. We're starting at F at 2 now. That's 30 plus 27 plus 23 plus 20 plus 18 plus 15 right there. Alright, so this is equal to 1/6 times, okay, and let's see here. So very quickly, 30 plus 27 plus 23 plus 20 plus 18 plus 15 equals 133. Alright, so 133. And then that's about equal to, let's see, 133 divided by 6 divided by 6 is equal to 22.16. So about equal to 22.166. So about 167. Let's see. Alright. Let's see what that is. Alright, that's actually about 1.167 is 1/6. So so that is equal to 22 and 1/6. That's what I wanted to do to make sure I got this. So it is equal to that. So our right approximation is 22 and 1/6. Okay. Alright, like that. And if you were to add these up and divide by 2, you would actually get the trapezoidal sum. You wouldn't even have to do the trapezoidal if you already did the left and the right, because you actually did do the trapezoidal, so by doing both of these, but you get an average. Alright, so we can do that. Let's see if we can figure this out. Let's see. I'm going to get the average of that, but I am going to do the trapezoidal with this, by the way. But I'm going to use these same numbers each time. But right now I'm just doing left and right. Okay, so only thing you got to remember, guys and girls and whoever else, men and women, is that you just got to remember when you're doing the left, you're doing F at 2, F at 0, F at 2, F at 4, F at 6, all the way except for the last one. If you're doing the right rule, then you're going to leave off the left one and you're going to go all the way to the right. Or you can start from the right and go to the left and leave off the last one on the end. Okay. Alright, so let's get the average of this. I can do this on, so we're getting an average And already these are averages, but we want the average of these two. Alright, so average is 23 2/3 plus 22 1/6 divided by 2. Okay, that's what you're doing. I can do it by hand either way. I might just do it by calculator. Let's see what I get if I do it this way. 23 well, let's see. Let's see. I'm just going to do it. Let's see. Let's do it by. Okay. And then, all right. I'm getting. Let's see. 22.916. Okay, that's about equal to 22.916. Repeats. So you can do 7 there if you want to. It's about equal to that. Okay, that's what I have there. That is 275 over 12 actually. It's 275 over 12 if you want to look at it that way. Okay, that's what I got out of that. Okay, and about 22.917. And again, that's what you would get if you did the trapezoidal rule there. But again, we're just dealing with left and right approximations today. And later on I'll do the midpoint and trapezoidal. I'll do those two probably in the same lesson. Okay, and then we'll probably get into what we call the definite integral. So I do appreciate everyone, guys and girls, men and women. I'm sorry I didn't know that. I thought I had a little time. See, my wife was going to wash and rinse the dishes, and I was going to dry them and put them up. So I need to get on out there and help her out a little bit. And, I don't want to. I mean, I love doing this, but you know, I've got to please my wife too. All right. Thank you so much for listening. Please hit the subscribe button. I am getting a few more subscribers, and I appreciate that very much. Please make a comment if you need to. Well done, KP the Math G, or I could show you something easier or better than this. Or I noticed a mistake that you made. Please point out anything that you believe I've done incorrectly, especially if I've done it incorrectly. But feel free to show me where I've done wrong. If you have seen an error, just show me where I've done wrong, and I'll change that in the next video. Okay? But feel free to comment. I appreciate your comments if you want to comment. Again, hit that subscribe button if you will. But you don't have to. It's all good. I just want you to learn how to do this. This is my main goal anyway. All right. KP the Math G signing off. Have a great day.